Okay, Algebra 3, we are going to be doing some notes about adding and subtracting rational expressions. Remember that rational expressions mean fractions. So we've got to be thinking in terms of how we add and subtract fractions. So one thing we got to pay attention to is whether or not we have common denominators or our denominators are different. So if we have the same denominator, all we're going to do is add or subtract the numerators, keep the denominator the same, and then simplify by factoring and canceling. If we have different denominators, we're going to have to do a little bit more work. Different denominators, the first thing we need to do is get the LCD. So we need to make it have the same denominator. And we do that by factoring the denominators. Then we're going to multiply each term by something over itself so that all the denominators match exactly. Then they are going to be the same. So we'll go back up here to where we have the same denominator, and we'll follow those instructions from before. So let's look at what it's going to look like to figure out an LCD. So an LCD has to exactly match. And so what we're looking at is once it's factored, so x times x plus 7 and x plus 7 times x minus 7. So in order for us to get the common denominator, we've got to figure out, it's like having two siblings and like they both want to have exactly the same thing. So if we look at our first little bit here, we have x and we have x plus 7. So we look over at the second one, and this guy has x plus 7 and x minus 7. So we look at, we want to compare. So the orange dude has an x and the green dude does not have an x. So we want to be able to give this one an x. So the LCD is going to contain an x. Then we look again. The orange dude also has an x plus 7, which the green dude has as well. So x plus 7 is a part of our GCF. And now we've dealt with both of those. So we look over here. We've already given an x plus 7, but we need an x minus 7 as well. So that LCD would be x times x plus 7 times x minus 7. We'll get more practice on that, don't worry. Okie dokie. So here are some examples. In this first one right here, 11 over 5x minus 1 over 5x. We can see that they already have the same denominator. So all we're going to do is add or subtract the numerators, keep the denominators the same, and then simplify by factoring and canceling. So I'm going to add or subtract the numerators. So that's going to be 11 minus 1. So that's going to be 10. I keep the denominator the same, so 10 over 5x. And then I want to see, can I simplify the numerator? Well, I see that the 10 and the 5 can both be divided by 5. So I'll do that. And then the numerator is going to be a 2. 10 divided by 5 is 2. And the denominator will just be an x. So that would be my final answer. Okay, this example here. Looking at the denominators, they are not the same. So I want to figure out what would be the common denominator. So I look at the 12. 12 would be, could be rewritten as 2 times 2, which is 4, times 3, so that's 12, and then x, x, and y. So that's this denominator, 12, x squared y. 2 times 2 is 4, times 3 is 12, x times x is x squared, and y. The other denominator, 6, can be written as 2 times 3, and then x and y. So to figure out what these denominators need in order to get them to be the same, they both have 2's, so we're good there. They both have a 3, so we're good there. They both have an x, and they both have a y. Now, whatever the orange one is missing, we need to give it. So it needs to get a 2 and an x. So I'm going to multiply by the same thing over itself. So I'm going to go times 2x times 2x. And then I'm going to end up having the same denominator. So this first one didn't change, 5 over 12x squared y minus. Now I have to do 11 times 2x, so that's going to be 22x. And then when I multiply this, I get 6 times 2 would be 12x squared and y, so 12x squared y. So now I have a common denominator, so I go back over to these instructions, add or subtract the numerators, and keep the denominators the same. So I will be doing subtraction, 5 minus 22x, and I keep the denominator the same, 12x squared y. And then I want to see, is there anything I can simplify with? Well, remember that in order to simplify, which we did in section 1, we'd have to have the same exact thing to be able to cancel, like we did here, the 5s. Nothing here can cancel because the 5 minus 22x is glued together, so this would be as simple as that could get. Okay, number 4. We can see here that we have the same denominator already. So we're on these instructions, add or subtract the numerators, keep the denominator the same, and then simplify. So I am going to be doing 4 plus p. So I'll have 4 plus p, and then it's over the same denominator of p squared plus 7p plus 12. Now I need to be able to simplify, and the steps for simplifying are going to be to first factor and then see if we can cancel anything. So I'm going to need to factor p squared plus 7p plus 12. So I do first times third, so 12p squared. Looking for something that adds up to plus 7p. That'll be 3p and 4p. So I've got p squared plus 3p plus 4p plus 12 from that. And then I group. So p comes out of that, so that would be p times p plus 3. Group here, and 4 can come out. So that'll be 4 times p plus 3. So I have p plus 3 in one parenthesis and p plus 4 in the other. So I have 4 plus p in the numerator, and I have p plus 3 times p plus 4 in the denominator. Well, because the p plus 4 down here matches the 4 plus p, because remember 4 plus p is equal to p plus 4 by the commutative property of addition, I can go ahead and cancel the 4 plus p and the p plus 4, which leaves a 1 in both of those spaces, so that my final answer in the numerator will be a 1, and in the denominator I'll have p plus 3 times 1, which just leaves me p plus 3. And that would be my answer. Okay, next example. This one has denominators that are different. So, different denominators. I want to factor the denominators and then multiply each term by something over something so that the denominators match exactly. So my first thing is to factor the denominators. So I'm going to keep that numerator the same. This denominator has a GCF of 4. So that'll be 4 times 3 plus x. This denominator has a GCF of 3. So I have a subtraction sign. The 7 stays the same in the numerator, and I'll have 3 times 3 plus x. Now, in order to get these denominators to match exactly, the 3 plus x already matches, but this one has a 4, and this one has a 3. So I'll need to give this one a 3 in the top and bottom so that it has 3 times 4. And I'll need to give this one a 4 in the top and bottom. So now I have 3 plus x, and 4. Here I have 3, 4, and 3 plus x. So now they're going to be the same. So I'll rewrite these. So that will be 15, because I have to do times 3. 15 over, I'm going to make that 12 times 3 plus x. And then a subtraction. And then 7 times 4 would be 28 over 12 times 3 plus x. Now I can go ahead and do my subtraction problem because I have the same denominator. So I will add or subtract the numerators and keep the denominator the same. So I'm going to do 15 subtract 28. That is negative 13. And keep the denominator of 12 times 3 plus x. Then check to see if I can simplify, which I cannot. So that will be my final answer. Let's see what the next page has in store for us. Okay, oh gosh, now we have 3 terms. But we're going to do the same steps, so no need to panic. I can see my denominators are not the same. So my first step is going to be that I need to factor the denominators. So 5 over x plus 2, or excuse me, x minus 2 cannot be factored. It's already simple. But what I'll do is put it in a parenthesis just to help myself out. And then I'm going to leave some space because I know I'm going to be multiplying by things. So I'm going to go plus, and I'll go 4 over x. I'll go ahead and put that in a parenthesis, and then leave a space because x won't factor, but this guy will. 2 over, there's a GCF here of x. So that will be x times x minus 2. Okay. Now the denominators are not the same, but once they're factored, then I can see what each one needs in order to be matchy-matchy. So this first one has an x minus 2. This one has an x. This one has an x and an x minus 2. So to make them match, they're all going to need an x times an x minus 2. Since this one already has an x minus 2, I'll just need a times x and a times x. And since this one has an x, I will need an x minus 2 and x minus 2. Now here's one thing that we want to keep in mind. When we are working with these rational expressions, what we want to do is not multiply the denominators out. We want to keep them x times x minus 2. But what we do need to do is multiply the numerators out. So we are going to do 5 times x, which is 5x. And we're going to have to distribute 4 times x and 4 times negative 2. So that will be 4x minus 8. And then we're going to keep this as a 2 because it did not change. And then we just add the numerators and keep the denominator the same. So essentially what we're doing, is taking this whole problem and putting it in the numerator like that, and then combining like terms. So here we would have 5x plus 4x, so 9x, and then negative 8 plus 2 is minus 6, and that's over x times x minus 2. Now we're supposed to see if we can simplify it all. So since the denominator is already factored, we just leave it at x times x minus 2. And then we want to see, can the numerator factor? Well, I see that there is a GCF of 3. So I can take 3 out, and that leaves 3x minus 2. Now, is there anything that I can cancel? I mean, I know it's super tempting to cancel the x minus 2 and the x minus 2, but those don't match exactly because that is a 3x minus 2. So those can't cancel. So this is as simple as that is going to get. Okay, next example. This guy has some factoring that we can do. So that's how we'll start. We will factor the denominators. So if you're super fast at factoring, these problems will go quicker for you than if you take longer to factor. So we'll do our factoring over here. So we're going to take first times the third, so 6x squared We need to add up to get negative 5x in the middle. So in order to do that, to get a positive here, both signs have to be the same. To get a negative here, they're both going to have to be negative. So that'll be negative 2x, negative 3x. So we got x squared minus 2x minus 3x plus 6. And then group. So we'll take an x out of this group, which will be x times x minus 2. This group starts with a negative, which means we have to take out a negative. So we'll take out a negative 3. So negative 3 times negative 3 over negative 3 is just going to leave us x. 6 over negative 3 is negative 2. So we'll have x minus 2 for one parenthesis, x minus 2, and then x minus 3 for the other. Okay, then x squared minus 4x plus 4. So take the first times the third, so 4x squared. We need to add up to the middle of negative 4x. And again, since this is positive, I either need to be plus plus or minus minus. But I'm going to have to be minus minus in order to get a negative here. So what multiplies to give positive 4 but adds to give negative 4, that'd be negative 2x, negative 2x. So then we rewrite. So I've got x squared minus 2x plus 4. Group, you can take x out here. So it's x minus 2. Group here. It starts with a negative, so I have to divide out a negative, and 2 can go into both. So negative 2, negative 2x over negative 2 is x. 4 over negative 2 is negative 2. So I've got x minus 2 for one parenthesis and, x minus 2 for the other as well. So let's go about making ourselves have a common denominator. So I look at this denominator. It's got an x minus 2 and an x minus 3. So we look over here, and this denominator is saying, okay, well, you've got an x minus 3 and I don't, so give me an x minus 3. So we're going to do times x minus 3 here and x minus 3 here. Now, this denominator is looking at that denominator and saying, wait a second, I only have 2 things and you have 3 things. We both have an x minus 2 and an x minus 3, but you've got 2 x minus 2s, so I also want 2 x minus 2s. So we're going to give this guy another x minus 2. So now both of our denominators will have x minus 2, and x minus 3. So x minus 2, x minus 2, x minus 3. And that's a subtraction problem. Don't forget that little guy. X minus 2, x minus 2, x minus 3. Okay. Now remember what I said. Don't multiply out your denominators, but do multiply out your numerators. So I'm going to distribute this 3 into the x and the negative 2. So that's going to be 3x minus 6. And I'm going to distribute this 2 into the x and the minus 3. So that's going to be 2x minus 6. So now my problem, if I put it all together over one denominator and made it one big problem, like I did that one, then I'm going to have 3x minus 6. Then I have a subtraction sign. And when that happens, I have to remember that this whole thing is subtracted. So it's subtract the parenthesis 2x minus 6. So then what I'm really doing is 3x minus 6 minus 2x, but plus 6. So I'm going to end up with the same denominator, x minus 2, x minus 2, x minus 3. But the numerator is going to be 3x minus 2x, which is x, negative 6 plus 6, which is nothing. It's 0. So I end up with x over x minus 2, x minus 2, x minus 3. Now, if you wanted to, you could write this x minus 2 squared times x minus 3. but that's up to you. Okay, we're on our last problem here, guys. We have 3 over x minus 4 minus 3 over 4 minus x. So here's a trick I can show you to save a little bit of time when this kind of a thing happens. See how the x minus 4 and the 4 minus x are almost the same? Well, we can take this negative right here, and we could put it either out in front where it is now, or we could put it to the top, or we could put it to the bottom. Well, what I'm going to have us do is put it to the bottom. So I'm going to keep this first thing, 3 over x minus 4. But then I'm going to move that subtraction, which is going to make it be a plus, and I'm going to put it to the bottom. So now I'm going to have negative 4 minus x there and keep that 3. Now, this isn't a trick that I would be like, oh yeah, you should totally already know how to do this. But I'm showing it to you to kind of save us some time, because what we can do now with that negative is we can distribute that negative, which is like multiplying everything times -1. So now our problem, the first part is 3 over x minus 4. That hasn't changed. And then we have plus, the numerator stayed a 3. When I distribute that, that's going to be -1 times 4 is -4. -1 times -x is plus x. Now, do you see what's happening here? What's happening is if I rearrange the order of this denominator, instead of putting -4 plus x, if I put x plus -4, which is the same as x minus 4, now I have the same denominator. And when I have the same denominator, all I have to do is combine my numerators. So I'm doing 3 plus 3 and keep my denominator the same. So now I'm at my final answer of 6 over x minus 4.